July 20th, 1969 changed absolutely everything. Neil Armstrong and Buzz Aldrin became the first people ever to walk on the moon. It was a huge moment in human history. By landing on the moon, the United States finally won the space race against the Soviet Union.
It's one small step for man, one giant leap for mankind.
This event helped weaken the power of USSR, and the US finally won. It was the end of the communism era. No, I was joking. The 1989 was end. The next day, the moon landing was shown on television. The broadcast lasted only 143 minutes, but around 530 million people watched it. Soon after, people started saying the moon landing was fake. Why? Because at that time, two big scandals happened in America. The first scandal was called the Pentagon Papers. These documents showed that the US government lied about the Gulf of Tonkin incident. This event was the main reason why America entered the Vietnam War. In reality, the war was a huge failure for the United States. The second scandal was Watergate. President Richard Nixon didn't want to lose power, so he secretly formed a group to find dirt on his political opponents. Imagine if your president secretly tried to sabotage another candidate just to win an election. What I'm trying to say is that 1960s and 1970s were tough times for America. The war in Vietnam was expensive, inflation was rising fast, and their US economy almost collapsed. Meanwhile, the Soviet Union was gaining power. They sent the first satellite called Sputnik in space. They sent the first animal, a dog named Waika, the first man, Yuri Gagarin, and the first woman into space, Valentina Tereshkova. America was clearly losing the space race. These space missions were extremely expensive for Soviets too, and this cost helped weaken them over time, but however, who cares? Their propaganda, Soviet propaganda, was very effective. At this point, even a small spark could start World War III, and the US would probably lose. America needed to show the world that they were still number one. They needed a big win. That's why in 1961, President John Kennedy stood in front of Congress and promised that America would go to the moon. Oh, he didn't lie, right?
We choose to go to the moon in this decade and do the other things, not because they are easy, but because they are hard.
The Apollo missions cost about $26 billion back then, which today would be around $127 billion. Moreover, more than 400,000 people worked on the Apollo program. Finally, astronauts went into space, landed on the moon, took videos, and everything looked perfect. The whole team became national heroes, while the USSR fell to its knees. But in 1976, Bill Kaysing published a book called We Never Went to the Moon, and things started to look suspicious. The book became very popular and made the people start doubting the moon landing. Why did people listen to Bill Kaysing? Because he actually worked for America's space program. Between 1956 and 1963, he worked at Rocketdyne, a company that built rocket engines for Saturn V, the rocket that later flew people to the moon. But things got even stranger in 1978. A filmmaker named Peter Hyams made a movie about astronauts landing on Mars, Capricorn 1. The movie was recorded here on Earth, but it looked almost exactly like the footage from the moon landing. This made people think even more that the moon landing might be faked and filmed in the studio. There are two main ways to record moving images. First, we have film. This is physical photographic tape, like the kind used in old movies. It's made of light-sensitive material, and each frame is a real photo, printed one after another on the strip. Second, there is a video, an electronic signal recorded onto magnetic tape or digital store. This is what you see in regular TV broadcasts, VHS tapes or live streams. Movies are actually filmed at 24 frames per second, because movies are shot on a real photographic tape. And 24 frames per second was the lowest number that was still looked smooth to the human eye. It saved money and film material. And what about TV shows? they are typically 25 or 30 frames per second, depending on the country. That's because TV uses electronic video, not film. It records straight onto magnetic tape or digital storage, and it can be broadcast live. But there is another reason for those frame rates. Early video systems were designed to match the local electricity frequency. In the US, the power grid runs at 60 Hz. So TVs used 30 frames per second, because 30 times 2 equals 60. Okay, it's easy math. In Europe, it's 50 Hz, so they used 25 frames per second, because 25 times 2 equals 50. Okay, it's simple. But the original moon landing video was not like that. It was recorded using a special TV camera that sent a live signal to Earth using a format called SSTV, slow scan television. It showed only 10 frames per second and in a black and white, so it was bad. The camera was custom built to survive the moon environment. That signal wasn't saved on the moon, it was transmitted live, straight to the Earth, through antennas on the Lunar module, by the way. On Earth, ground stations received the signal and converted it in real time in a regular TV format, NTSC. So it could be recorded on magnetic videotapes and broadcast on television. So the footage we see today here wasn't filmed and brought back. It was streamed live from the moon using 1960s technology. And the saddest part? Listen, NASA later lost the original high-quality SSTV recordings. The best version we have now are the lower quality copies made on here on Earth. But even if the footage was streamed live, could it have been altered? What if they filmed it in a studio? Because some people say NASA could have faked it in a studio and just slowed the footage down to make it look like a moon gravity. But here's the thing, slowing down video like that takes a lot frames per second and a lot of data. For example, if you record something at 60 frames per second and then play it back at 30 frames per second, the motion looks slower. It's logical. This is called overclocking. But in 1969, video equipment couldn't really handle that. The best slow motion recorders could only store 30 seconds of video, and that gave you just maybe 19 seconds of slow-mo playback in the best way. So faking 143 minutes of moon footage with slow motion, this is totally impossible. But wait, what if they didn't use video at all? What if NASA used film reels, the classic kind used in Hollywood? With film, you can speed things up or slow them easily. After filming, you can convert it to video and show it on TV. But here's another problem. Thinking that much on physical film would require massive amounts of tape. A single roll of 35mm film lasts about, 11 minutes maybe, and is 300 meters long. To capture all the moon footage, all 143 minutes, even at low frame rates, you would need over 6.5 rolls. That's almost 2 kilometers of film. I wish you luck. And once recorded, you would have to cut and join all these strips. But splicing film leaves behind tiny, really tiny errors. Scratches, dust, hair, light leaks, none of those show up in the Apollo footage. And by the way, later Apollo missions were recorded at 30 frames per second, so if you think faking Apollo 11 would be hard, faking those would have been 3 times harder. But okay, in recent years, NASA's Lunar Reconnaissance Orbiter even photographed the Apollo landing sites. You can see the footprints and lander base still there. So did Apollo 11 really happen? Well, some still doubt it. For example, look at the American flag in the official NASA photo. It looks like it's moving in the wind, but there is no air on the moon, right? It's vacuum. So why it's moving? Why it's waving? What the fuck? Think about flags here on Earth. If there's no wind, they hang down and don't move at all. NASA knew a flag wouldn't look good hanging flat, so they added a special horizontal metal rod. This little rod was supposed to hold the flag straight, but it didn't fully extend, making the flag look like it was blowing in the wind. But it wasn't. There was simply a mechanical problem. Another common argument is that you can't see stars in the moon photos. The reason is seriously simple. The astronauts landed in daylight. The moon's surface was brightly lit by the sun. Also, astronauts wore bright white spacesuits that reflected a lot of sunlight. Cameras had very short exposure times. With such short exposure, bright objects, like astronauts or the moon's surface, show clearly, but small dim objects like stars become invisible. For example, think about trying to take a photo outside at night with bright still lights nearby. If your camera uses a very short exposure time, you won't see any stars. The camera settings required for bright scenes simply don't allow weaker lights such as stars to appear. That's just basic physics and optics. And by the way, astronauts also had another source of light on the moon. The Earth itself. Sunlight reflecting on the Earth's surface was strong enough to light even shadowed areas slightly. This is why in some Apollo 11 photos you see strange shadows. Who took this famous moon photo? You can clearly see Neil Armstrong reflected in Buzz Aldrin's helmet. Some skeptics ask, why isn't Armstrong holding a camera in his hands? What he's doing? I know. It was aliens. Aliens. You know, the answer is easy. Armstrong couldn't carry a regular camera on the moon like tourists do. He wore a spacesuit weighing nearly 100 kilograms. Astronauts needed cameras that were easy to use on the moon, so NASA placed the cameras directly on the front of the spacesuits at the chest level. This allowed astronauts to easily take photos without using their hands. But there's one more problem people often mention, and this is seriously problem: the Von Allen radiation belts. These belts are areas of strong radiation around the Earth, shaped like a donut. Inside them are charged particles coming from the solar wind. Some people think that astronauts couldn't pass through these belts without getting dangerous, even deadly amounts of radiation. And in fact, NASA worried about this before Apollo 11. They wondered, will our astronauts survive? And to protect them, NASA used special shielding made mostly of aluminum. Scientists also carefully planned a safe road from Earth to the moon. This road minimalized the astronauts' time inside the radiation belts. And after the Apollo missions, NASA measured radiation exposure from all 9 missions that reached the moon. They discovered that astronauts received only about 0.46 or 46 Rad of radiation. This amount is actually smaller than what some nuclear power plant workers experience. It's also about 10 times smaller than the radiation doctors and medical workers get from working with X-ray machines. So maybe we were on the moon's surface. But you are still not convinced? Okay, here is one final fact to think about. 50 years ago, during Apollo 11, Armstrong and Aldrin placed special laser reflectors on the moon's surface. These reflectors are still there, and scientists on Earth use them even today, maybe even now. By bouncing lasers of these reflectors, we can measure the distance from the Earth to the moon, down to centimeter. But why haven't we returned to the moon yet? One big reason is money. The Apollo missions cost about $26 billion back then in the 1960s and 70s. So if we adjust that for inflation today and add something special, it would be around $160 billion. A lot. And remember, only 12 people actually walked on the moon. That means America spent over 2, maybe $2.5 billion per astronaut just to take those historic steps. Pretty expensive footsteps, right? Back then, landing on the moon wasn't about science or exploring minerals. It was mostly a show. A way for the USA to tell the world, look, we are stronger than the Soviet Union. Look at our biceps, tricep, chest. Yeah. We are the best. We rule the world, baby. Once the goal was achieved, there was simply no good reason to keep spending such huge amounts of money on moon missions. But times are changing, we are in 2025. Right now, NASA and other space agencies have new plans to go back to the moon, and this time they are serious about staying there. Recent studies show that the moon could be full of valuable minerals like helium-3, which might help us create new kind of energy here on our planet, on Earth. Companies and countries are already planning how they can mine the moon's surface. So it's not question of if, but when we will go back. But wait, if we go back and start mining, I wonder how will the mysterious residents of the moon dark sides feel about it. They will fight or they will surrender. But hey, that's a story for another episode. Let me know what you think.